All right, this is now chapter 2. This is going to be the chapter of reasoning. So the first two sections that we're going to go over is inductive reasoning and finding the nth term. So let's define what inductive reasoning is to begin with. It's the process of observing data, recognizing patterns, and making generalizations about those patterns. Okay, so that whole sentence is important. So it's a process of observing data, recognizing the patterns, making some generalizations about those patterns. Conjecture. The conjecture is the generalization that you made from using inductive reasoning. So let's try some inductive reasoning. So it says use inductive reasoning to find the next three terms. Consider the given sequences. So let me get my pen. So we have the first one right here. It says 2, 4, 7, 11. 2, 4, 7, 11. So first thing that I automatically go to is what are the differences for the 2? So it jumps up 2 from there to there. And then it jumps up 3 from there to there. That's messy. Sorry, let me do that again. So it goes up 2, and then it goes up 3, and then it goes up 4. So I already see a pattern right there. So the next one's going to probably go up 5. So 5 plus the 11, this next one will be 16. And then it's going to go up 6. So then the next one will be 22. And then now it's going to go up 7. And that'll be 29. So I have to see what the pattern is. On this next one, let's go off and think of the first thing like we did earlier. Let's look at the differences. It goes up 2, goes up 3, but then it goes up 5. So that's not anything that's going to help me right there, okay? So can't look at that. One thing that I recognize right here is when I see this 3 and a 5 and then an 8, automatically what pops up into my head is 3 plus the 5 equals the 8. So 3 plus 5 equals 8. So let's go look at the next one. Does 5 plus 8 equal 13? Yes, it does. So obviously I'm adding the two previous terms to get the next one. So what is 8 plus 13? That's 21. So 21 is our next term. And then I want to add 21 plus 13. That is 33. And then what is 21 plus 33? 54. And those are my next three terms. So I'm using inductive reasoning. Sometimes it's multiplication, guys. Sometimes I can multiply. Sometimes I can add. Sometimes I can subtract. So up here I was adding 2 to the previous number, and then adding 3, then adding 4, then adding 5. Over here I was adding the two terms to get the next. So 3 plus 5. So those were both different types of patterns there. Look at this next pattern. This next pattern deals with an actual picture of patterns. Okay, so I have a circle and I have some polygons. So I'm going to use inductive reasoning to draw the next two figures. So one thing that I like to do is I like to number the terms. So this is term number 1, 2, 3, 4, 5, 6. Okay. So the next one that I'm going to do is 7 and 8. So the 7th term looks like it has to be a circle. So I'm going to draw a circle. And then it's obviously cut in half because all of the circles have been cut in half. So it's cut in half, shaded on top, left, bottom. So the next one I'm going to guess is going to be shaded on the right. The 8th term is going to be a polygon. So let's investigate and look at the polygons. So I've got a triangle, then a pentagon, then a 1, 2, 3, 4, 5, 6, 7, a heptagon. So this one has 3 sides, 5 sides, and then 7 sides. So notice that pattern, 3, 5, 7. So the next one must be a nonagon. So I want to draw a nonagon. This might be a little tough. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, good enough. And then they all have the same colored dots or circles inside the figure. Okay, so just to be sure you can understand what that is, this is a nonagon. Okay, so now it jumps even a little bit more difficult. It says draw the 25th figure and then draw the 30th figure. So now we have to kind of start looking at patterns that look way ahead. So we want to start thinking of maybe some type of either a rule or an equation that I could apply. So one thing that I do notice is all the odd numbers, all the odd numbered terms are circles. So the 25th is an odd number, so we know that that's going to be a circle. We just don't know where it's going to be shaded. And then obviously when we draw the 30th, that's an even, so it's going to be a polygon. What type of polygon? Probably one that we probably can't draw, so we're gonna just name what type of polygon it would be. So in the second term, we have a 3-sided polygon. In the fourth term, we have a 5-sided polygon. In the sixth, we have a 7-sided polygon. And in the eighth, we have a 9-sided polygon. So if you'll notice on every term, it's the polygon has one more. If you add 1 to the term, that's the type of polygon that it is. So if I'm looking at the 30th figure, this is going to be a 31-gon. Okay, it's going to be a 31-gon, and it's going to still have those little circles and dots. Okay, so I'm not going to attempt to draw that one. Okay, but it would look basically some sort of crazy 31-gon, and then you have the circles at the bottom, and then the colored in circle up at the top. Okay, so now the 25th figure I want to kind of figure out. Okay, so let me tell you one thing that I learned about this pattern. Okay, I know that it's every other number. Okay, so like the top is shaded over here, and this is one quick easy way to do it. Then the left side is shaded next, then the bottom is shaded third, and then the right side is shaded next after that. Okay, this one was the first term, this one was the third term, this one was the fifth, and this one was the seventh. Now, of course, you can just easily go to 25. So this would be 9, 11, 13, 15, 17, 19. See, it doesn't take very long to get to 25. 21, 23, 25 is going to be the top shaded. Okay, so we know that it's going to be the top shaded. But what if, just to kind of extend on this type of problem, what if it said the 205th? Okay, what if it said, what would the 205th one look like? Okay, we know it's going to be a circle, but what would that be? So let me show you the pattern that I came up with on my own. So I looked at this right here. All odd numbers in a set is usually half of that, right? And so I did a couple of investigating on some of these numbers. So I looked at, let's say 25, okay? I divided it by 2 because, again, odd numbers are half in the set because the others are even. So 2 goes into that 12 times, right? And it's got a remainder of 1, okay? So it's got a remainder of 1. So then what I did after that was I took the 12, and there were 4 categories that it could be. So I took the 12 and I divided it, and I ignored that remainder of 1. And again, this is all me doing inductive reasoning. Okay, so I didn't know what to do with that remainder of 1 just yet. But then I took the 12 and I divided it by 4 categories, and 4 goes into that 3 times with a remainder of 0. Okay, so then I tried something different. I said, let me try the next one, which would be 27. So I'm going to take that 27, I'm going to divide by 2. 2 goes into that 13 times. n has a remainder of 1. So then I took the 13 and I divided by, and so then at that point I realized, oh, they're always going to have a remainder of 1 because I'm always dividing by 2, which is an even number, and all of these are odd. So I'm always going to have a remainder of 1, so I figured that's irrelevant. So then I took the 13 and I divided it by 4 because there's 4 categories, shading the top, the left, the bottom, and the right. So 4 goes into 13 3 times, and this one had a remainder of 1. So then I said, oh, how is that related to that? It's just 1 more, right? Well, let me try the next one, 29. 29. So I took 29, divided it by 2. 2 goes into that 14 times. Again, look, there's that remainder of 1, so see how that's irrelevant. Then I took the 14 and I divided it by 4. So if I get remainder of 2, I've got myself a pattern here. So 4 divided into 14 goes into that 3 times. And looky there, I have a remainder of 2. So guess what, guys? Every time I get that remainder of 0, it's going to be shaded on top. Every time I get that remainder of 1, it's going to be shaded on the left side. Every time I get remainder of 2, it's going to be shaded on the bottom. And obviously, the remainder of 3 is going to be shaded on the right side. So let's take 205 and figure it out. Okay, let me get a different colored pen. So I take 205, I divide by 2 to take care of my odd numbers. So it goes into that 1, 0, 2. So that's 204. Remember that remainder of 1's irrelevant. So then I take 102 and I divide by 4 because there's 4 categories. So 4 goes into that 2 times, that's 8. 2, 4 goes into 22 5 times, which is 20, and I have a remainder of 2. So which one did we say the remainder of 2 falls under? So this one was 0, 1, 2, 3. So this one's going to be shaded on the bottom. So the 205th one is going to be shaded on the bottom. See how you can do that? All of this that I did one time, of course I knew it from last year because I love this pattern and the years before. But I did inductive reasoning at one point in time to try to figure out what I could do to figure out any large number, okay? All right, so there's a picture pattern. Let's try one more picture pattern. It says use inductive reasoning to draw the next 2 figures. Okay, so just the next 2. So obviously they're all circles, so I know we're going to have circles here. In the first one, I have 1 segment. Okay, oh, and again, I like to number the terms. So this is going to be the 4th term, and this one's going to be the 5th term, like the picture, first picture, second picture, third. This one has 1 segment inside, or a chord. Remember, those are called chords. Over here, I've got 2 segments. One's a chord, and one is just a segment that goes from an endpoint on the circle and then kind of touches the other segment. Okay, but I've got 2 segments, this one and this one. Over here, I only have 1 segment. Okay, and it doesn't look like there's any type of way it is slanted or turned. So now let's look at the third one. I have 1 segment here, 2 segments, 3 segments, but you'll notice that one of the endpoints is on the previous segment. Same thing here. This one has an endpoint on the previous segment. Okay, so obviously this one has to have 4 segments. Okay, and there's only 1 chord. Okay, and that's that 1 chord up there. So I'm just going to draw 1 chord up here. I'm going to kind of copy what I've already have. So where do you think the next segment is going to go? It's obviously going to be connected from here, and the other endpoint needs to be on the circle. So maybe something like that. Okay. So then that's 4. So obviously this one's going to have 5 segments. So I'm going to have 1 up here. Then I'm going to connect from there. And I'm going to connect from there. Connect from there. That's 1, 2, 3, 4. And then of course I want one of the endpoints to be on the last segment, and there we go. So obviously you're going to probably draw these different ways as you continue the pattern, okay? So this one's not too difficult as far as the numbers go. I mean, the number of segments matches whatever term it is. So sometimes the patterns are easy. Sometimes it gets a little difficult on how you draw them though. You just have to kind of see and go off previous knowledge, investigate the first one, then the second one, and then the third. Okay, so let's move on to nth term. This is the second section. This is 2.2. So what is the nth term? Okay, so the rule that gives the nth term for a sequence is called the function rule. So this is kind of taking you back to Algebra 1. So you dealt with function rules, which you probably know them to be maybe an equation. So if you want to write an equation right under here, but we usually start an equation with y equals and then something where function rule, we're just going to write the rule, so to speak, which is the nth term. So it's related to an equation, however. Okay, so if you know the rule for a sequence, you can use it to calculate the 200th term or any term in the sequence. So this might be able to help us with like some of those previous patterns that we were looking at a second ago. So let's start looking at some rules here, okay? So here is the function rule, okay? So let me just label that right here. So right here, that's our function rule. So doesn't it look kind of like an equation other than the fact that it's not made with x and it doesn't have y equals? Okay, so that's our function rule. Same thing here. This is our function rule. See, and these are pretty easy function rules that I think you remember from Algebra 1. Okay, so those are our function rules. And then we have a table here and we just have to fill out the pattern. So all we need to do is investigate what's happening here. So this clearly looks like it is going up 1. So that means if it went up 1 these two times, that's going to be the same pattern. It's going to go up 1. And we don't even really need to use that rule unless we really want to. So for like 4 n minus 5, we would plug in the 4 right there. So 4 minus 5 is -1. Or like we said, the rule was, oh, it's going up 1 every single time. So the next one would be 0, 1, 2, and 3. Okay, so pretty easy rule there to add 1 every time. So one thing that I want to review that you might notice when we write the rule, the function rule, okay, which is also going to be known as the nth term. Anytime you have n right here, this is also known as the nth term. So you're going to hear me say nth term. Okay, again, it's the same thing as the function rule, which is kind of the same thing as the equation. So you'll remember n minus 5, the number right there, y'all remember last year from Algebra 1 that that's our slope. So sometimes students like to use their algebra to figure out these patterns. And then that number right there is the y-intercept. Okay, so if you want to utilize that to figure out the patterns, you could do that also. So this function rule is 4n minus 3. Let's just kind of look at the rule that's happening here. This one goes up 4. This one goes up another 4. So that means this is 13 because it's going to go up 4 again. Okay, and again, if you look at that number right there, that's our slope. So when the slope is a +4, that means it's going up 4 every time, so long as the values up here are going up by 1. If they're going up by another number, say 2, then we're going to have to make an adjustment to this value down here to make sure it is equivalent to the slope. So let's just continue with going up 4 every time. 4 plus 13 is 17, then 21, then 25, and then 29. All right, so that's pretty easy. So if they give us the rule, we can do that. Now just be careful. Sometimes they might ask you for the 500th term. Obviously, you're not going to continue counting by 4s. This is where you want to utilize the rule. So you would do the function rule. So you would do 4 times 500 minus 3. So 4 times 500 is 2,000. And then we're going to minus the 3. So 1,997. So that's what that would be. All right, let's look at the next one. So on the next one, they give us a pattern here. And they give us the first term, the second, third, fourth, fifth, sixth, and seventh. And then we need to figure out the nth term, okay, which is right here, okay, which is also known as a function rule. Remember, there's always a couple of different names for any mathematical term, okay? So like slope can be defined different ways. You can call it slope, you can call it rise over run, you can call it rate of change. All of those mean the same thing. So here, the function rule is also known as the nth term, like up here. So we're gonna use the nth term a lot. Okay, so let's look and see what it's changing by. This is going up by 7. And is it going up by 7 again? Yes, it is. So it's going up by 7, up by 7, up by 7, up by 7. So what would the rule be? Well, let me flip back for a quick second. When all of this went up by 1 every single time, the slope was 1 for this particular pattern. Over here was continuously rising up by 4. And what was the slope over here? 4. So if this is going up by 7, then we can start off by writing 7 in, because we know that's going to be our slope. So then how do we get, so to speak, the y-intercept? Where does this pattern start? So I always like to draw in a little 0 right there. So where did it start on the 0 term? Well, if I can go back 7 this way, so that would be 13, right? Which is also should be remembering from, you should be remembering that from what a y-intercept looks like. It's when 0 is your x value, and then that is your y-intercept. So plus 13. Okay, so I like using algebra to figure out the nth term. What would the 200th term be? Well, I kind of showed you that a second ago. So we can take our function rule, plug in 200 for n, and add 13. So this is going to be 1400 plus the 13, so 1413. Let's try another pattern. Okay, let's look and see what it changes by. This one went down 5. Looks like the same pattern, down 5 again, down 5 again, down 5, down 5. So again, these are all going up by 1s. Okay, so remember, as long as they're going up by 1s, then we can use this to be our slope. So this would be -5n. Okay, and I'm going to do the same little process that I did a second ago. I'm going to go back to as if this was 0. Okay, and so this one would be 12, right? Because that would take me down 5 like all the rest. So this would be -5n plus 12. So now let's figure out the 200th term. So I'm going to take -5, plug in 200, and add 12. So -5 times 200 is -1000. And then I'm going to add 12. So that would take me down to -988. And there's your 200th term. Okay, let's take a look at this next table. This next table is kind of weird. Okay, it does not have a simple 1, 2, 3, 4, 5 term. Okay, so it actually started out a negative number. So this one's where you're really going to have to remember your algebra. Started out at a -4, then went to -2, then to 6. So this has a different change other than 1. Let me get a different color here. So this one went up by, went from -4 to 2, so that means it went up 2. But then over here it didn't go up by 2, it went up by 8. So when from -2 to +6, that's 8 units that it went up. Now let's take a look at this change right here. So it went from 12 down 8. So this one went down 4. Over here, this one went down 16. Down 16. So think back to what rise over run looks like. Okay, rise over run. This would be the rise down here, and that would be the run. So that's like our slope. So our slope would be, when we look at these two right here, -4/2, which what does that reduce to? -2. Let's look at the other one, -16/8. What does that reduce to? -2. So if we were to rewrite this table, which is not a bad idea, we could rewrite -4 -3, -2, -1, 0, 1, 2, 3, 4, 5. I'm not going to go, well, I'm already there. Let's go to 6. Okay, so -4 was at 12, -2 was at 8, and 6 was at -8. Now, what did we come up with? Our slope, okay, our change is going down 2 technically for every single term. So that means this one would be not negative. This one would be 10. Okay. Then see how it went down 2 and then down 2. So is the next one down 2 because that's what we got over here when we look at the change, the rate of change. So that means this one would be 6 and then 4, then 2, then 0, and then -2, -4, -6, and then look, there's my -8 as we continue the pattern correctly. So sometimes it helps to make a new table, okay? So if you need to, make a new table with those values, okay? When it's out of order, it's kind of tough to see it at the beginning. So -2, so we have -2 as our slope in, okay? And remember, our y-intercept is what the next term is right here. So it's at 0, this is a 4. So there it is, -2 in plus 4. So now I'm able to utilize my rule, my function rule, -2, and plug in the 200 and add 4. So -2 times 200 is -400 plus 4 gives me -396. Okay, so some of these tables can be a little bit different depending on how they put the numbers for you. Okay, so you'll have some like that on your homework. You'll have some easy ones and some more challenging ones. All right, so again, we just found all of these that I'm about to highlight. These are all the nth term. That's the nth term. That is an nth term, also known as a function rule. This is an nth term. Okay, so when it tells you to find the nth term, that's what you're doing. And again, it's related to finding the equation, sort of, like in Algebra 1. All right, let's take a look at this last one. How many matchsticks would be in the 200th term? Find a rule first and then the nth term. So what is this pattern here? What is this rule? So what helps is if you make a table. So like this is the first picture, the second, the third. Then we can figure out what the fourth would look like. Okay, I think it looks like a real easy pattern. These are all pentagons. And look, these are all matchsticks. So I think it's pretty easy to see what's happening here. Okay, so there's my matchsticks. I even drew the fourth one. Now let's figure out the quantity, okay? Because that's how many, that's what the question is. How many matchsticks would be in that? Well, how many matchsticks are in the first picture? 5. How many matchsticks are in the second? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 matchsticks. Right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 matchsticks, okay? Let's see, I'm not even going to count the matchsticks in the one that I drew. Let's see what the pattern is. It went up 4, and then it went up 4 again. So this is probably going to go up 4 again. So this is what we have, a constant pattern again, kind of like all of our other patterns in this lesson. So this would be 17 matchsticks. Okay, so again, if it's going up by 4 every time, we know that that's going to be our slope. So let's use our algebra skills to write that down. The question is there any y-intercept? So let's go back 1 to 0. And if this one is going up 4, then that means at 0, it would be 1 matchstick, okay? The 0 term. And so we're going to put a +1. So the nth term, or the function rule, is 4n plus 1. So now to figure out how many matchsticks would be in the 200th, we just have to plug that in. So 800 plus 1 is 801 matchsticks. That is it.